Good afternoon and welcome to this UniTaster Tuesday. My name is John. I'm here from UniTasterDays and we run these UniTaster Tuesday events every single Tuesday, and they're all about supporting students with university guidance and making informed university decisions. This is one of our 2 o'clock events, which means we're going to be exploring, studying subjects at university, and today's subject is computer science, and I'm delighted to be joined by 2 exceptional speakers. Professor Jon Murray, who is joining us from the University of Hull, is going to open things up. Jon is going to talk about what to expect on a computer science course, and also to provide an overview as well of some of the career routes that graduates often go on to. And our second speaker is Adriana Wilde, who's joining us from the University of Winchester. And Adriana is going to look at some myth busting in terms of computer science and things often students think about that is the case and perhaps aren't the case. And that'll be a really useful introduction as well. But without further ado, if I can pass the floor to Professor Jon Murray, joining us from the University of Hull, for an introduction to computer science, including what to expect on a course and an overview of careers as well. Over to you, Jon.
So thank you very much for inviting me to talk about computer science and what computer science can offer in terms of careers. So I'll go through a bit about kind of projects we've been working on and advancements that we've taken computer science forward into industry, and show how computer science does have that real world application, applied kind of knowledge and theory to industry, jobs and careers. So without further ado, I shall put my presentation slides up and say welcome to the future of computer science. So computer science is one of those topics that moves incredibly quickly, and we'll have a little whistle-stop tour of that as we go through. But first, who am I? Why am I here to kind of talk to you about computer science? Well, I'm a professor of robotics and autonomous systems at the University of Hull. And I did my PhD in computational neuroscience. So I looked at how humans do things, how our brain works, and try to replicate that in some robots. My degree was in computer science, which is what I'm going to talk about today in terms of the subject area. And I also have a degree in electronic engineering as well. Some of my interests and what might kind of bring around about the things I'm talking about is robotics. And you can see if I'm ever unable to make a lecture, there's my replacement there. So that's Pepper, our robot, who also presents some of our lectures to our students. I do a lot of security work, so we look at how computer science can support security. So I work with the Home Office and Border Force. And we look at virtual reality and how virtual reality can be used as well for help and training and learning and education and those kinds of things. And I've got a passion, a hobby and a work passion for drones as well. So one of the things I like to do with my students when they come to the university is to ask them why they chose computer science. And we put a nice little word cloud together here of some of their responses. And as you can see, the most popular was computer science is the future. It's interesting. Money also interests students, you know, how much they can get in terms of a job and the salaries that computer science would offer. It's fast moving, it's innovative. Employment, the impact computer science has, and obviously my favorite word, cool. Computer science is certainly cool. So there's a kind of insight into current students and why they chose computer science. So there are kind of 3 main areas I like to talk about for computer science, about why study it as a subject. And the first is that computer scientists predominantly will design and build software. So we'll make applications, we'll make software to control things, maybe for Windows applications, for businesses, for industry, those kinds of things. So we design and build software for some purpose and some use. The second reason for computer science is to develop ways to solve computing problems. So how do we make computers better? How do we make computers more efficient? How do we make algorithms better? And that's another area of computer science. And the third one, which is the one that's kind of close to my home and my heart, is devise new and better ways of using computer science to solve other people's problems. So we look at climate change, we look at flood risk, we look at health and well-being, and how computer science can be used in those disciplines. You know, I work with medical companies, wound care healing companies, offshore wind companies, and how we can use computer science to improve what they do. So they're the kind of 3 reasons of why computer science might be good to study. So if we have a little look at the history here, so back in 1940, when computing was just kind of starting, this is the kind of thing you might expect. It was a mainframe that filled an entire building and could probably do 8 computations a second, which is quite impressive. If you try to add 8 numbers up a second, it's quite challenging. But now we're moving on to where we are today in 2020. We've got virtual reality. We've got a globe that is entirely connected. We can send an email from here to the other side of the world in less than a second. Computer science has progressed quite quickly. And the question is, what's the next 80 years kind of going to bring in terms of computer science? Some of the topics that computer science covers and some of the things you might see related to computer science are artificial intelligence, human-computer interaction, so how we engage with our computers. What does the Windows interface look like? How do we make it more intuitive and work with it a bit better? Virtual reality is a big part of computer science now. Software development, app creation, that kind of thing. Networks, databases, the more administrative side of computer science as well, and many, many more other areas that we look at in terms of topics. So here's a little example of some of the work computer science can be applied to, and this is a virtual reality project where working with an offshore wind company might want to look at how they can train in a safe environment some of their workers, and what they might want to do, as we did here with one of our students, is drop a worker from heights from a turbine. If there's danger, they need to evacuate them. So what we have here is a virtual reality headset. We've built and designed a VR model of what that turbine might be, and we can use a harness in the lab, and we can give them that feeling of actually falling down and see how they cope with it, see what the stress levels are like, and then find ways to manage that and support that. A little better video here kind of gives you the visual impression. So there's a fire in a wind turbine. How do we evacuate the crew? We attach them to the harness, and then obviously we lower them down through the escape route so a boat or ship can come and rescue them. So as a computer scientist, these are the kinds of projects you might be working on. These are the kinds of interests you might have, the kinds of things you might work with. Or you might be developing applications to support fire services. So using VR and graphics to do simulations and management of, if there's a fire in a particular street, where do you send your crew? How do you organize your crew? You might think, how's that computer science? Well, it's using the technologies that exist in computer science, as I mentioned before, to solve other people's problems, to help other areas, other domains. Computing is very pervasive. It's everywhere. It's in our phones, it's in our smart TVs. Everywhere we go, there's computers around us. And a computer scientist has had to design and develop that technology. Here's another example. So this is a Waymo driverless car that's driving around with no driver. And how did this come about? Well, it came about from computer science technologies. So we might have students designing their own road networks using small robots to see how they can do collision avoidance, how they can understand and interpret roundabouts and those kinds of things. From there, we apply technology to video footage. So this is a dash cam footage from one of my colleagues. He kindly sent through. And what we can do on the left is we've got the dash cam. On the right, we can actually see what a computer can detect in real time. And it picks up things that I certainly missed in that video. There was a pedestrian on a bike by the rail crossing, which I didn't see. But computers do. We might need, again, some colleague loaned me some footage of their dash cam. We've run it through an algorithm that's developed by a computer scientist. And what we've got here is a car knowing which side of the road to drive on. So it highlights the lane by which the car needs to remain on. And this is purely just from visual information. So that's the kind of technology that computer science might be applied to. So we then take that information, we take that technology, computer scientists will graduate, go and work for companies that work, developing the next driverless car, the next automated technology. You may have heard of Industry 4.0. So Amazon, for example, good old Jeff Bezos, has automated lots of their warehouses and have thousands of robots that are moving around, interacting with people. Those robots require sensors. Those sensors have been designed by engineers and computer scientists. They're programmed by computer scientists. The testing is done by computer scientists. The deployments might be done by engineers with computer scientists supporting them. So, as a discipline, we get absolutely everywhere. So, in terms of kind of the background of computer science and the technologies that it can apply to, where's my destination? Where can you actually go and work as a computer scientist? What kind of jobs might there be out there? Well, you might pass through a checkout. Unfortunately, due to COVID at the moment, it's not the kind of thing we do as regularly as we used to, but you might pass through a checkout in a supermarket, and the software that runs on these systems that scan the barcode on your product, that total how much food you've bought and what the cost of your food is all designed, developed by computer scientists. The stock management system, when the barcode's scanned, it might go off and say, we're running low on baked beans, and that'll go off to another system. And again, all developed by computer scientists. The SpaceX rockets, there are literally hundreds of thousands of lines of code in these rockets that allow them to land back on the spot where they took off. So what we're doing here is we're not only pushing forward the boundaries of space exploration, but we're being green as well. Computer science is helping us be green because we can reuse rockets rather than dispose them in the sea or have to rebuild new ones. And computer science, is involved very deeply in these kinds of areas. Another application might be using computer science for security, for health and safety, for well-being. And what we've got here is a real-time identification and tracking system on a rail platform, which can just take camera feed and can segment out, and you see it's highlighted the individuals. This is all in real time, and told you if it's a person. The little box in the top right corner there, I've just zoomed in on an image. And what it's also done is told you that this person has a handbag, and it's identified that handbag, and it's 97% certain that it's a handbag. And that's all done through the development of software by computer scientists. One of the other things I did last night is I had a look at Indeed, and I did a quick search for computer science to see just that term, not software development, not software engineers, not testers, not designers, not robotics, not programmers, just computer science. And currently on Indeed, there are over 5,500 jobs waiting for people to take up. So from that perspective, when we think about computer science, there's lots of jobs out there, there's lots of work available, but more interestingly than that is computer science is everywhere, and it's such an exciting subject. Everything you might interact with in terms of technology has something from a computer scientist in it. So where does this leave you? Well, gives you knowledge in computer science as a subject, gives you skills in writing code, skills in software engineering, skills in managing software projects. As computer scientists, we certainly have to do that, and team working skills, and many, many other skills, hardware, networking, AI, vision, all these kinds of things. But it certainly leaves you employable as a graduate, and that is without a doubt. So that really is a kind of brief outline around the technology of computer science, the kinds of areas it covers, the kinds of applications that it can be used for, and really about the employability of computer scientists. Yeah, so I hope that's been interesting. I hope that's given you some insight. Thank you very much.
Thank you very much, John. That was Professor Jon Murray joining us from the University of Hull. What an interesting presentation. Really, really enjoyed that. And it's funny, I didn't spot the pedestrian either. So it's funny when you look at stuff that the computers can do that perhaps humans aren't as good at.
Absolutely.
Absolutely incredible. And students watching live or watching back on the recording, I'm sure that's really whet appetite for courses and careers in computer science. So big thank you to Professor Jon Murray. You joined us from the University of Hull. Our second speaker today is Adriana Wilde, who's joining us from the University of Winchester. And Adriana is going to look at some myth busting in terms of computer science. And I'm not going to say any more about it than that, because I don't want to ruin things for you. So with that, I'll pass straight over to Adriana Wilde, lecturer with the University of Winchester, for myth busting computer science, please.
Thank you very much, John. It's been a pleasure to be here, and also a tough act to follow there, Professor Jon Murray, showing us his side of it. I found very interesting to hear what the students told you when they enrolled your courses and what brought them to computer science. And it's very interesting because it's pretty much what brought me too. It's that thirst for the future and that thirst for problem solving and that curiosity. So I hope that my presentation will also show you that, transpire that for you. So what I wanted to share with you is what I call this myth busting for computer science, because I think despite all the popularity of this topic, and then despite so much that we know about it because it's everywhere, there's still quite a few myths there. And as I go and bust these myths, as mentioned before, I am working at the University of Winchester, but also I've been trained and have worked before at the University of Southampton as my little history of employment and education, which show a bit of a potted history here of my education here at the bottom. That will see you may notice for my accent that I am not British. I'm born and bred in Venezuela, where I did my first degree in computer science. And then I have been involved in many different aspects of education and doing a PGCE and did a master's also in computer science in Switzerland, a joint master with 3 universities in Bern, Neuchâtel and Fribourg. And now I'm finishing my PhD in Southampton. And that is my background, in my education, but also my employment. So I did tell you that there are lots of interesting careers around it. So though most of my employment has been regarding education and teaching and training, there have been some dabbling in industry, like working with Centractive, helping build software and web pages and things like that, that no doubt it's one of the things that you would be familiar with as an end user of computers. But I'll skip this bit and tell you what my research interests have been lately. So these are the list of my most cited publications. And then you see perhaps a theme emerging there, and that also will let you see a little bit more about my real interest in computer science and when you see that pattern emerging. So like things about smart home control, human activity detection technologies, making predictions about things that happens in education, perhaps looking at lots of data, and you can make use artificial intelligence or machine learning algorithms to make those accurate predictions or what you want it to be accurate. Also looking at the electronic side of things, and you can do that it's used for Internet of Things that you perhaps have heard too. More about HCI, which is human-computer interaction, and how that impacts also educational technology. So it's not just, it's the computer science, it's a discipline that is touching so many other areas, like Professor Murray was saying before, so many other areas of human knowledge and concern, so including education. And pervasive systems is another area in part of computer science, so in which you have that combination of not just the algorithms that process the instructions that, that you perhaps have heard, but also where is the data coming from. So you have sensors like the cameras that we're saying, that you have a multitude of different type of inputs that you may want to process real time in order to make those decisions now that help us in our day-to-day life. And further to that, you will see more things about activity recognition, again, healthcare settings. So there are other areas in which computer science in my life has made a big impact. And the thing that I see around it that drives me is the interest in artificial intelligence, but also human-centric computing. Yes, I am interested in building software and solving problems, but the ultimate aim for me and for many that study this profession, work on this profession, is to make the human in the center and to facilitate their lives. So here we have, like, kind of this visual kind of collation of all the different areas. Obviously, computer science education is a big one in my case, but you ask any other computer scientist and they will tell you other aspects. They're more driven towards data science, or you know, there will be many, many things. And that's, I think, probably one of the most fascinating things about our topic, that it's so young, because 80 years really is young for a discipline, you know, compared to others, yet it's so broad, and it's no way you can get bored here, really. You will be able to find an aspect of this profession that excites you. And I did say that I'm really passionate about putting the human in the center, and that my research is about that too, but also my teaching. So one of the pleasures that I'm sure Professor Murray will share with me in having this, having pursued this career, is the opportunity to teach others that are also interested in this, you know, kind of, you get that kind of feedback of, you know, you're not only solving problems for your own curiosity, but you're able to inspire others to pursue that problem solving. And then these people become your colleagues, you know, they become people who with you are building a new future. So this student of mine that I just showed you a picture of her graduation, then she's presented some academic work, and I was perfectly happy for her to present it on my behalf, because she's my colleague now. And in fact, she finished her PhD before I finished my own. You know, it's such a pleasure to be able to be with like-minded people that are sharing the same interest and passion about making a world a better one with technology. And, you know, many students, I love pictures of graduations. This is one other case I wanted to show you about a student of mine. That she is working on a smart home. So it's one of the things I'm quite interested in. So her background was in software engineering, but now she's also using data that has been that has been collated for identifying how to support people living independently in their old age in a smart home, or so-called smart homes, so environments that can become smarter by the use of sensors. So this is one of the things that, for example, you can see the application of these technologies that will actually make a difference to people. Other students of mine have been looking at aspects of detecting falls. So imagine if you are an elderly person living independently, and if you have a fall, would you be able to tell somebody to come and help if you are on your own? Maybe you don't even have mental capacity to do that once you fall, for example. And technology now is already able to do that. And people like these students are able to develop algorithms and study algorithms to increase the accuracy for these detections to actually help people and make a big difference. Obviously, with all of these innovations, there are issues with acceptability and ethical use, and these are other aspects that we explore in computer science. It's not just about the code and the technology, but about the human perception of it, how we can make these more friendly and protecting the human from that perspective. And okay, I think I'm just going to go directly to what I think we should, the myths we should bust. So I hope that by now you know that all I do is not just programming. So the first myth that I got here in the top right, all you do is programming when you are a computer scientist. That is not true. You have a fundamental interest, of course, in building software. Yes, you do have programming. I'm not saying that you're not going to do any programming, but you have a fundamental interest in solving problems that are meaningful, that are sufficiently difficult that just without technology you cannot do. You know, that are interesting in that way, that have that complexity that it's worth exploring. So yes, it's not just programming, or not all the time are programming. A lot of the time you are just staring at that blank screen trying to figure out what to do next, what's the next thing to do now, because that is one of the big things, you know, creation and yeah, innovation. The other myth I would like to bust is that you need to be programming from a very young age. I've been involved in doing UCAS interviews, as some of you would probably be already thinking about making a personal statement and applying to universities. And on these interviews I have, on reading the statements, I have seen lots of people saying, okay, I first wanted to study computer science since I was 5 when I got given my first computer or something like that. Yes, I'm not doubting some people would be like that, but that doesn't mean that if you didn't have that privilege of that opportunity or that even that curiosity at that time, that doesn't mean that that's it, you're done for life, you cannot access computer science. In fact, the best programming courses, they won't even ask you to have had an A-level in computer science. All we ask is that you have a good understanding of maths and you have that capability to attack complex problems and decompose them. So you do have to have a mathematical mind, a systematic approach and that kind of discipline. But you don't really need to have been even interested in computer science since you were very, very young. And I think it's worth posting that one. And the other one, it's that it tends to attract people who are interested in computer games because they are amazing. You know, the things that you see, the computer graphics that are behind that, and all you know, the advances in the software and also the hardware that has allowed that realistic effects in computer games has made an impact in lots of people, and they tend to think that much of what we do is that, and not necessarily so. And I hope that by showing you all the different things that we've been interested in, me personally in my career, but you know, the potential in the discipline, it's not just about that, and it goes beyond that. It's also about, real problems beyond entertainment. It's not necessarily an elitist career. So one interesting thing about computer science, as opposed to other disciplines, that it's taught similarly in different parts of the world. So you may not have had, for example, if you were choosing, I don't want to talk badly about any other disciplines, but some are very, very dependent on the geography. Like, for example, if you were going to study law, and you are here in the UK, so you are very, very much regarding studying the context of this country and the laws of this country, and that doesn't necessarily translate well if you go abroad. So it's a big step sometimes to kind of revalidate your, even medicine or many others, you may have heard that doesn't travel well. Computer science does. And it doesn't really care much about your previous background. So people do, as long as they have that mathematical background, you will find that actually, because there is so much funding related to that, you may have scholarships that, you know, there is one of the disciplines in which you can have opportunities that make it more accessible, even for people who don't have a very privileged background. So it's perhaps one of the least elitist careers there is, precisely because of that. If you know how to look and where to look, there will be opportunities for this, provided that you have the talent and the inclination, you know, that I keep stressing the mathematics. Finally, I hope by now also, you know, there's not a career just for men. It is true that now the gender balance is not, if you go and go to most universities, you will see there is a bit of an underrepresentation of women, but it hasn't always been like that. One of the pictures that we saw earlier when we had the very early computers, actually, they were all operated by women. So this shift in the gender balance has happened since the advent of the PCs, perhaps as an unhappy accident of marketing, you know, how it was seen as increasingly a career for men. But none of the attributes required for being a computer scientist are gender related. So as long as you believe that you have the interest, it's really no barrier. And in fact, especially nowadays, because many companies and many governments, they want to address that current state of affairs of the gender balance not being quite what we wanted. There are things like, yes, scholarships and special opportunities for people of other genders. So definitely not just a career for only men. And yeah, I think I covered most of the things I wanted to say regarding that. It's basically for curious minds, people who are interested in problem solving for big problems, big problems that would transform the world and will help us be in a better place. So if that sounds like you, I think you perhaps should consider, explore more, find out a bit more, what are the topics and different places they cover in computer science. Ask questions, find people who are computer scientists, make connections. People will be only very happy to give you some more information about their experiences in computer science. And I believe we will have some time now to answer any questions you may have. But that's all I have for now to say.
Thank you very much, Adriana. Really, really good session. Adriana, you've just clicked stop share. Yeah, you've beat me to it. So really useful to have your own personal career journey as well, going from how you've got into profession, which followed on really nicely from Jon in terms of what Jon was saying previously about different career opportunities, and then looking at some common myths as well. Really, really useful. We don't actually usually run Q&As live any longer, but actually we one that I've been answering some questions while where you've been presenting, and one that came in was actually about application tips, and a student, I won't mention the name, but the student asked about they're interested in applying for computer science, and they're asking about personal statements. So I gave them a bit of information about general advice and different approaches, but I'm wondering from actual practitioners if there's anything that you'd love to see in a student's personal statement if they were applying to you.
I would like to see honesty. Sometimes people want, I want to say the right thing that gets me in. But then you interview them and you really broke a computer apart when you were 5? Really? I mean, you are a genius, eh? I would like to have you. But then you start prodding that and actually they trip over. Just be honest. Just be honest. If you say, actually, I just got interested in computer science after I finished my A-level in maths because whatever. That is fine, but just be honest. I think it will be the most important thing. I don't know what.
Yeah, Jon, could I come to you? Anything else?
Yeah, I'd absolutely agree with that. I tell applicants to stay away from phrases such as "I work well as a team" or "on my own individually." These are just common phrases that everyone puts on personal statements and CVs and applications, and they mean nothing without evidence and context, which your personal statement doesn't have enough space for. What I would say is exactly what Adriana said: is just be honest. Be enthusiastic and passionate about the subject. Why computer science? What is it about computer science that has drawn you in, that makes you really excited about it? Just tell us why you've got the passion for it. What I want to see is someone with a passion for the subject, because they're the students that shine, and they're the students that really take to it really well.
Brilliant, thank you, Jon. And then just the final one, and if anyone is watching live, we won't be able to take any more, but you can always email me after the event and I'll try and get answers for you. But the final one, actually, if you were currently a student's watching this that's in year 12, so 16, 17 years old, exploring options, do you have any tips of what they can do other than achieve great grades at school in terms of to really maximize their chances of getting a university place, but maybe in terms of their careers afterwards? And Adriana or Jon, whichever, if anyone can jump in first. It's a really tricky one to ask, but probably great advice for students. Yeah,
it's kind of, so some computer science degree programs will require specific A-levels and some won't. So it's having a look at that first before you make kind of A-level decisions. But extracurricular, it's all about getting involved in other things, extracurricular. There's about, rough rule of thumb, there's about 100 students per university, and there's about 100 universities that graduate computer science students every year in the UK. That's a lot of graduates that are coming out into the market. What's going to make you step up above the other students? And that's extracurricular stuff. Get involved in hackathons, game jams, personal projects, build a portfolio, get a GitHub account, put your work on GitHub. all that kind of thing to show that you're really passionate about the subject.
I would like to just add something about hackathons, because there is a perception it's just, you know, men coding, drinking beer and eating pizza. There is no, I mean, there are other kind of hackathons. So just find something that you would like to do. But the important thing is that the opportunity to work with other people, solving a problem with the time pressure that you have to deliver something at the end of it. And it's so rewarding, you know, starting from nothing, from just a very generic brief, and then coming up with a prototype of something that it's just very rewarding. And it's what I'm saying, is about creativity and you know, problem solving. And do seek those opportunities and don't be put off by, okay, there are too many of this particular, and because we want actually people like you. So do get engaged in all these things and find the best for you.